Topic 2 in the prerequisite module of Algebra 2 will be finding the average rate of change. And there's only one objective in this topic, and it is to find the average rate of change based off of what the problem is giving you. I'm going to do 3 different examples. The first example will be based off if you're given a graph of a function. The second example will be based off if you're given a table of a function. And finally, the function itself down below. So to begin, let's look at a graph of a function. And let's talk, before we even get into this, we have to talk about what the average rate of change is. You have discussed something very similar to this in Algebra 1, something called slope of a function. And more specifically, rise over run, or the change in y's over the change in x's. And then finally, what that breaks down to, over any given interval, reading left to right, what are the change in y's over the change in x's? So this formula you will have to memorize for this class, because you're going to see this a lot moving forward, finding the average rate of change. It's going to be y2 minus y1 over x2 minus x1. So you need to find 4 values to input into this formula. So please write that formula down and memorize it. It is necessary for this class. Now, typically the interval will be given to you as x values. So if I'm going to model how to do number 1, it says look at the graph of this function x squared plus 1. What is the average rate of change between -1 and 3? So that interval, -1 to 3, those are the x values. That's my x1 and my x2 value. And so if you see up in the top right-hand side there, typed in red says step 1. I've listed out the steps I would take to solve this type of problem. It says identify the y values from the given x values. And so that is going to be my first step if I was to model how to do this. I have a given x value of -1. And because, reading like a book left to right, -1 is listed first, I can call that x1. So I have one piece of my formula that I'm going to input later. So at -1, I have to then look at the picture of my graph and see what is the y value at -1. At -1, which is right here, the y value is already dotted for you, right there. So at -1, it goes up 1, up 2. So at -1, it is 2. So that is my y1. They go hand in hand. x1, y1. And then at 3, what is my y value? So 3 is over here. And my y value is 1, 2, 3, 4, 5, 6, 7, 8, 9. Matching up with that dot. So my y value is 9. So I have done step 1. I've identified the y values based off the given x value. So I'm done with that step. Moving on then to step 2, I'm going to input these values into my formula and solve the formula. Let me go ahead and label, this is x2, this is y2. So I've labeled everything, and now I know exactly what to input into my formula. I'm going to switch up colors. Step 2 then will be y2 minus y1. So my y2 is 9 minus my y1, which is 2. These two values right here. Over my x2 is 3, and my x1 is -1. In this case, please be careful that by default, the formula is subtraction, so I'm going to write 3 minus, but this 1 is negative, so I have to put 3 minus a -1. Please be very careful with your negative signs if they show up. So I've inputted the values into the formula as so, and now I go ahead and just solve the numerator and the denominator. So 9 minus 2 is 7, over 3 minus a -1, minus a negative becomes positive, so 3 plus 1 is 4. At times your answer might be a whole number, other times it might be an improper fraction like this, or just a regular fraction. But if it is in fraction form, you can go ahead and leave it like that. So my final answer is 7/4. Now, please be aware while you're doing these problems, an area where you can make a mistake is identifying the y values based off of the x values. Please always consider how they list them. -1, 3 over here, -1. The first number listed will always be your x1 value. The second number listed would be your x2 value. And then the y1 will always be paired with the x1 and vice versa. So go ahead and pause the video and try number 2 on your own. Given the graph, see if you can first identify the y values, input them into the formula, and solve for the average rate of change. You should have paused the video and tried number 2 on your own. The answer, please check your answer with mine. I got -3/2 for my average rate of change. So again, if you didn't get that answer, please check with a neighbor or raise your hand and I will come over and check your work with you. Now if you notice, and then I'm going to erase this so I can talk about it quick over here in this graph. Reading a graph left to right, because the average rate of change always travels from left to right. The first rate of change in number 1 was positive 7/4. And if you notice, we are indeed rise over run going up first, so in the positive direction. We go up 7 and over 1, 2, 3, 4. Up 7/4. Down here, it makes sense that this is -3/2, or the slope is negative, or the average rate of change is negative, because reading left to right, we start going down first and then over, like so. All right, moving on. Average rate of change if given a table. So again, I'm going to do an example, then I'll have you try one on your own. Table is pretty straightforward as well. The first step is always to identify the y value if given the x value. And these are my x values. They want to know the interval between -1 and 3. So I'm going to put -1, and this is going to be my x1. What is my y1 value at -1? Well, here is -1. So my y value at -1 is -11. At that x value right here, the y value that matches it is -11. So that's my y1. Found the first one. The second one is at 3, my y value is -27. So x2, y2. I did step 1. I've identified my y values. Now moving on to step 2, I'm going to input them into my average rate of change formula. y2 minus y1, so -27 minus -11 over 3 minus -1. I guarantee someone will forget to put minus and negative here, -27 minus a -11, or 3 minus a -1, so you will get the wrong answer if you're working through one of these problems. Please always be careful about working with your negatives. After I input it into the formula, I can go ahead and solve. -27 minus a -11 plus, so -27 plus 11 is a -16 over 3 minus a -1 plus, so 3 plus 1 is 4. Now in this situation, I'm given an improper fraction, but this can be reduced, and so I will always ask you to reduce your fractions as far as they can go. So if I were to reduce -16 over 4, -16 divided by 4 is a -4. So my final answer is -4. The average rate of change over this interval is a -4. So that tells me that the slope is going down. So go ahead and pause the video and try number 4 on your own. You should have paused the video and tried number 4 on your own. I got a slope of 0. If you notice, the two y values are the same thing, and whenever that is the case, anything minus itself will be 0, and 0 divided by anything will always be 0 as well. So go ahead and check your answer, make sure it's the same as mine. If not, please raise your hands and we can talk about it. And then finally, the final example that we're going to talk through is finding the average rate of change if given the function itself. This is where you're going to have to use your prior knowledge of evaluating a function, because you're given two x values, you need to find out the y values of those x values. So for the first step, you're going to have to do a little math of inputting the x values into the function to get an output of the y value. So I'm going to show my math there. And so if I was to model this, consider the function y equals x squared plus 4. What is the average rate between the two x values of 1 and 5? So my first step of finding the y value is instead of, if you recall from prior knowledge, instead of writing x squared, I'm going to put parentheses squared because I'm going to input a number into that variable, plus 4. My first number I'm going to input is 1, and that will equal, so 1 squared is 1, plus 4 is 5. So my first coordinate point is 1, the x value of 1, which is x1, comma 5, which is y1. Now, let me do that for the second number. Parentheses squared plus 4. Again, I'm taking my function. Instead of writing x, I'm writing a parenthesis, and I'm inputting each x value into the x to get my y value at that specific x value. And instead of 1, I'm going to write 5 this time because I care about my x2 value. In this case, 5 squared is 25. 25 plus 4 is 29. So my second coordinate point is 5, 29. And that's my x2, that's my y2. So if I were to get given or graph this function, x squared plus 4, and you went over to the x value of 1, the corresponding y value at that x value would be 5, and the same thing for at the x value of 5, the corresponding y value of that graph would be 29. Similar process, just a different way to find the x and y values. So that's my first step. Second step then would be to input them into the formula and solve for the average rate of change. My y2 is 29, y2 minus y1. My y1 is 5. Over my x2, which is 5, minus my x1, which is 1. So 29 minus 5 is 24. 5 minus 1 is 4. This can be reduced. 24, again, fractions are just talking about division, so technically this is always numerator divided by the denominator. So 24 divided by 4 is 6. And I'm done. So go ahead and pause the video and try the last one on your own, number 8. Alright, at this point you should have paused the video and try number 8 on your own. Please check your work with mine. I did it step by step. I inputted the values into my function, the x values into my function, which gave me the y values, which are right here. Let's see, y values. And if you notice, the y values are the same. Whenever the y values are the same, your numerator will be 0. Over here, 24 minus 24 is 0. And 0 divided by anything is 0. So the average rate of change over this interval of -3 to 3 is 0. Please raise your hand if your work and your answer does not look like mine.